Hey all you well-protected folks out there, this is Julian from Sophos Support, and today we're talking all about Wi-Fi and preparing to deploy Sophos wireless access points. Whether you're deploying a new wireless network or making changes to an existing network, there's a lot of factors to consider. This can be a pretty complicated process, so we've put together some info to get you started on the right foot and avoid problems like slow or inconsistent Wi-Fi connections. In this video, we'll be going over the following topics: wireless frequency fundamentals, network requirements, site surveys and heat maps, and some additional considerations directly from support. Let's start by talking about frequencies. Wireless networks can function off two different frequency bands, 2.4 and 5 GHz. Now, it's important to understand the attributes of both frequencies as they'll both have pros and cons in your environment. The 2.4 frequency band can penetrate objects better than 5 GHz, so it can achieve a longer range in your environment. It's a shared frequency band, so APs aren't the only devices that use 2.4 GHz. Other devices like cordless phones, microwaves, and Bluetooth devices also use 2.4 GHz, so they can actually cause interference on a 2.4 network. The 2.4 frequency band has 11 different channels that data can be transmitted on, but only 3 channels, 1, 6, and 11, are non-overlapping. This means 1, 6, and 11 are the only channels we can use without running into channel overlap issues. We'll talk more about channels shortly. Our other frequency band option is 5 GHz. Now, 5 GHz is less susceptible to channel interference, but more susceptible to signal degradation. 5 GHz is a higher frequency, so its waveforms are much smaller and faster than 2.4 GHz. It's more difficult for higher frequencies to penetrate objects, but they have a faster transmission rate, meaning much faster potential speeds. 5 GHz has 24 non-overlapping channels, so a lot more to choose from. Because of that, its channels are less likely to get congested due to high traffic or interfere with each other if multiple APs are close together. Now, not all devices support 5 GHz, so make sure you evaluate your client device requirements and AP capabilities before selecting a band to use. We'll talk more about that in the network requirements section. Now let's talk about channels. The concept of channels can be a bit confusing, but here at Support, we see a lot of cases caused by misconfigured channel selection and width, so it's very important to understand. Basically, each band can have dedicated lanes that traffic can be transmitted on. The more data being transmitted on one lane means the more likely congestion can occur. So if your network and a neighboring network, for example, are both using channel 1, it's potentially double the traffic on channel 1. This can cause major co-channel interference, or CCI, on both networks. CCI is crosstalk from two different radio transmitters or antennas on the same channel. When this happens, you can experience anything from just slow Wi-Fi to as far as completely unusable Wi-Fi, even though your device shows fully connected. In this scenario, it's best to switch your AP to a different non-overlapping channel, like 6 or 11, and that should resolve the issue. A channel is essentially a segment of the frequency band that can be either 20, 40, 80, or 160 MHz wide. 2.4 GHz can actually only accommodate a maximum of 40 MHz wide, since the entire range is only 72 MHz wide itself. The wider the channel, the more throughput capability it has, which means potentially faster Wi-Fi. Think about a channel like a highway. If you double the amount of lanes, you can double the amount of traffic. This comes with a price, however, as the wider the channel is, the less channels you have, and more so, the less non-overlapping channels you have. This raises the likelihood of adjacent channel interference occurring. Adjacent channel interference occurs when 2 or more channels overlap with each other. For example, if you have 2 APs both using 2.4 GHz, one on channel 1 and one on channel 2, since those 2 channels overlap, the signals will interfere with each other. In this situation, again, you would want to choose channel 1 for the first AP and channel 6 or 11 for the second AP because they don't overlap. Essentially the same resolution as the first scenario. In most networks, we tend to keep channels at 20 or 40 MHz max width to increase the amount of non-overlapping channels we have to work with. But obviously that means we're sacrificing potential throughput. If you plan on using 5 GHz with 80 or 160 MHz channels, yes, you can get great speeds, but make sure you're either not near other networks or you really plan your channel selection well. Like many access points, Sophos APs can actually be configured with automatic channel selection. So the AP will detect the channel with the least amount of traffic and switch to that channel. This is convenient in simple setups like home or a small office with a few APs, but sometimes high-density environments deploying many APs, it may be best to statically assign channels to ensure APs aren't constantly switching between channels. Next, let's talk about the needs of your own network. You need to identify the following information to help you plan your wireless network design: applications that'll be in use on your network, number of simultaneous clients, types of clients, areas to be covered, and power availability. Different applications have different throughput requirements. For example, voice over IP has a minimum bandwidth requirement of 100 kilobits per second up and down, but 3 megabits per second is recommended. 1080p video streaming has a recommended bandwidth requirement of 5 megabits per second, and 4K streaming has a recommended 8 to 20 megabits per second. Now, these all don't sound a lot, but if you have 50 users on Skype calls at the same time, you need at least 150 megabits per second network to meet the recommended throughput requirement. So take note of the applications that'll be in use on the network and make sure you find out the throughput requirements. You always want to make sure your network can handle more than required, because more bandwidth will result in a lot less frustrated users than not enough. Most networks have more than one user, so knowing the amount of simultaneous users on your network is extremely important. Wi-Fi is a turn-by-turn system, meaning every device takes turns transmitting and receiving data, not all at the same time. An AP can either receive or transmit data at any given moment. So 50 users on your network means 50 turns being taken, sending and receiving data, even though it seems seamless when deployed well. Next, you want to know the type of client devices as well. Different devices use different wireless technologies housed under the 802.11 protocol suite. Take a look at this chart here. Each standard of the protocol supports different bands and speeds, as we can see, the fastest being 802.11 AC, which only supports 5 GHz. Many modern devices will use 802.11n, which support both 2.4 and 5 GHz and is backwards compatible. This is not all devices, however, so it's important to know what devices are going to be on your network. 802.11a, b, and g are older wireless technologies, so they have slower transmission speeds. If you have legacy devices on your network, this can actually sometimes slow down your network speeds dramatically, since each device takes turns transmitting and receiving data. The N and AC devices may be speeding along, but they may get slowed down waiting behind the B devices, for example. When deploying, you can use a setting called band steering to direct 5 GHz clients to use 5 GHz and 2.4 GHz clients to use 2.4 GHz. This is basically like creating a fast lane on a highway so faster clients don't get slowed down. The newer Sophos APX series access points support all the 802.11 standards we just spoke about. However, the older AP series vary per model. So make sure you know what standards your access points support. Wireless devices can use multiple antennas to transmit more data through a process called MIMO, multiple in, multiple out. A laptop, for example, can have up to 3 antennas, whereas a smartphone usually only has 1 or 2 to conserve battery power. Take a look at this chart. Looking at 802.11 AC, we can see that with one spatial stream or one antenna on a 20 MHz channel, the max bandwidth is only 87 megabits per second, but 3 streams, it's 289 megabits per second. So if your wireless devices only have one antenna, even if you're using 802.11 AC, your maximum throughput for that device can still only be 433 megabits per second if using an 80 MHz channel. If you're deploying many access points, chances are you can't use 80 MHz channels, as you would limit the amount of non-overlapping channels available. So you're more likely using 20 or 40 MHz, meaning those devices have a maximum throughput of 87 or 200 megabits per second. So no matter how fast your access point is, your network is really only as fast as the clients that use it. The next thing you definitely want to know is the areas that need coverage. Make sure you note areas that need heavy coverage. For example, if the majority of users are connected in one section of the office, the APs in that area would then have significantly more simultaneous clients connected to them. This could mean you need more APs in that area to distribute the traffic, which will require more planning. Sophos APs have been tested with 60 devices connected at once, all transmitting data with little degradation, but every network will vary depending on the applications in use and the environment. It's generally a good rule to limit the simultaneous clients for each AP to around 30. Another thing to keep in mind is that different building materials can affect wireless signals significantly. Drywall and insulation will block far less signal than thick concrete. However, in some parts of the world, there may be metallic coating between the drywall and the insulation that actually blocks wireless signals significantly. If your site has wood or metal covered walls, depending on the thickness, this could also seriously impede the signal. So keep that in mind while planning, and be sure to find out what building materials are used if you're experiencing issues. In terms of power availability, Sophos APs can be powered through power over Ethernet or DC power. Some AP models can be powered through both, while some only PoE. So be sure to know what your APs require. Make sure you know what infrastructure your site has available for PoE, and keep in mind that APs can require more power on boot than advertised. So be sure your PSE can supply more than the minimum requirements. If an access point doesn't receive enough power, it can actually start rebooting randomly. Now, the best way to plan your wireless deployment specific to your site is to perform a site survey. There are 3 different types of site surveys: passive, active, and predictive. Passive surveys are listening surveys. They don't actually send out any traffic to the network, just monitor radio frequencies in the area. This can detect other APs in the area, their signal strength, the channels in use, signal to noise ratio in the area, and other useful information. This is the most common type of survey because it's simple and you don't actually need to have any APs installed. There's tons of different applications to perform passive surveys. You can even download free apps for your smartphones. However, smartphones aren't designed specifically to do this, so may not give you the most accurate response. Active site surveys are a lot more in-depth. For an active site survey, you send and receive data on the network to get exact measurements. These are done to deploy and troubleshoot wireless networks as you measure things like throughput rates, packet loss, as well as all of the information from passive site surveys. When actively surveying a site, you typically create a wireless heat map as well to get a visual on the radio frequency strengths. Heat maps are great because you can really see where your problem areas are. Predictive site surveys are simulated site surveys. For example, in Sophos Central Wi-Fi, you can upload an image of a 2-scale floor diagram and place simulated access points to predict placement. Since you input an exact distance scale, this can show a good representation of access point range on your site. You can use many tools to do this, but remember, a simulation can really only show range. It can't really account for building materials and interference sometimes. All three types of surveys are useful, and there's tons of tools you can find online to perform site surveys. Now let's talk about some additional considerations directly from Sophos support engineers. If you find there's a section of your site where devices AP hop, either increasing transmit power for one AP or decreasing transmit power for the other AP may be an acceptable solution. If your APs don't connect directly to the gateway and go via a layer 3 switch, create a static route for the magic IP 1234 and route to the gateway. If using Sophos Central Wi-Fi, allow access to the FQDN wifi.central.sophos.com. There should not be any web filtering or HTTPS inspection applied to the traffic destined to or originating from the AP, as this causes problems for registration with Sophos Cloud Wi-Fi. More SSIDs means more overhead. Be careful adding too many SSIDs, as this creates more management frames for your AP to handle, which could impact performance. Each AP can handle a maximum of 8 SSIDs, and that includes the mesh SSID if mesh is in use. If you choose to use the most compatible encryption, TKIP plus AES, remember that the throughput and performance is greatly reduced due to TKIP's processing requirements. We suggest to use AES only and use a separate AP for older clients that will only work with TKIP. So thanks for watching, everyone. If you had any further questions, feel free to check out the documentation links in the video description or view and post questions at community.sophos.com. That's it for me today. Stay safe out there.